Okay, imagine yourself driving on the highway at 120 kilometers per hour. Smooth, fast, there's no need to step on the brake. Now, imagine there is construction in progress on the highway. What happens? You start to slow down your car and suddenly the traffic is bumper to bumper. Well, same thing in the form of water flowing in a river filled with vegetation. Vegetation becomes resistance to the river flow. They reduce the flow velocity, causing the water level to go higher up to the floodplains and cause flooding. This doesn't mean vegetation is all bad. Vegetation is able to stabilize the river banks and reduce erosion. They are also good for the ecosystem as they act as water filter. So, how do you decide how much vegetation is needed to preserve the environment and at the same time doesn't increase the flood extent? One way to do this is to represent the vegetation resistance in the form of roughness factors in a 2D model to see how the flow behaves due to vegetation. A dominant vegetation property that can represent this resistance is density. There have been many studies in measuring vegetation density, but none of them is applicable as they are time and cost-consuming. Can you imagine going to the field to measure vegetation one by one, or doing lab experiments to cover all vegetation types? No. This is where my research comes into the picture. My research aims to propose a quantitative methodology in measuring vegetation density for 2D flood modeling. How am I going to do this? I'm going to use a high-resolution satellite image and perform scientific image processing to classify the different densities. Based on the new parameters describing the different densities, I will develop a new formula to convert them into the roughness factors. These roughness factors can then be input in the 2D model to predict flow patterns and water levels. To verify the results, I'm going to compare them against historical flood events. Why is it so important? Well, this new practical framework will help land use planners and engineers in maximizing river management, focusing on vegetation maintenance in strategic areas. This in return will help protect the river and reduce the flood risk, a winning combo that will make both people and Mother Earth very